Hello friends, today I will be explaining you about IPv4 addressing and subnetting, and then I will simulate some topologies in the Cisco packet tracer. So IPv4 addressing and subnetting, here you can see what does it mean by hardware addressing. Hardware addressing is used to uniquely identify a host within a local network. Hardware addressing is a function of the data link layer of the OSI model. And then let me skip all these things and then come to the IPv4 addressing. IP address provides a hierarchical structure to both uniquely identify a host and what network that host exists on. And then to do subnetting, you should be familiar with the decimal to binary conversion and the binary to decimal conversion. Here comes the subnet mask. So subnet mask is a part of an IP address which identifies the network. The other part of the address identifies the host. So here you can see the above IP address has a subnet mask of 255.255.0.00. It follows two rules. The first one is if a binary bit is set to a 1 in a subnet mask, the corresponding bit in the address identifies the network. If a binary bit is set to 0 in a subnet mask, the corresponding bit in the address identifies the host. So here you can see this both it is host. Wherever it's 0, it's host. So to learn about IP addressing and subnetting, you need to know more about this thing, that is classes. The IPv4 addresses has been structured into several classes. Value of the first octet of an address determines the classes of the network. So class A, the first octet ranges from 1 to 127. Class B 128 to 191. Class C 192 to 223, and class D 224 to 239. And the subnet mask is also class A is 255.0.0.0. It means that first octet is the network portion, and the rest three octets defines the host. You can see the first octet defines the network and the last three octet defines the host. In class B, first two octets defines the network and the last two octet defines the network. So suppose for this IP address 158.80.164.3. So can you guess what would be the class of this? So you can see how you can identify. I'll tell you. So now just remember this first 158. Okay, only we should be concerned about this first octet. So in first octet we have 158. Now come to this classes, and here you can see 158 lies between 128 and 191. So you can see it is of class B, and then the default subnet mask is 255.255.0.0. So you can see it. ah, you can see this belongs to class B address, so the subnet mask is 255.255.0.0. So before you do subnetting, I have just a simple tips I want to give it to you, that is, please be familiar with the classes and the IP addressing. Okay, so then only it will be easy for you. Even I suffered, but when I learned this concept about IP addressing the classes, then like it seemed very easy to me. So I hope it will help you. So now for the third experiment, I have been given this scenario, and I need to perform subnetting in this topology. So after this, based on this topology, some questions are asked. Based on the topology, how many subnets are needed? So this means how many networks are needed. So we can see this is one network, this is another network, this is one of the networks. So we have one network, second network, third network, fourth network, and fifth network. So we need five networks. So this is five networks. Now, how many bits must be borrowed to support the number of subnets in the following table? See, we need how many networks? 1, 2, 3, 4, and 5 networks. So every time when we see, it's always in the power of 2. So 2 power 2 is 4. So we can't afford 5 networks in that 4. So we need 2 power 3, that is 8 networks. So we need more 3 uh, bits to be borrowed in that from the topology table. So how many subnets does this create? I already told you 2 power 3, that is 8. So how many usable hosts does this create per subnet? That is 30. Now calculate the binary value for the first 5 subnets. The first subnet is done, that is 0000. And then since we are borrowing 3 bits, see, you can see the first 3 bits are changed: 001, 010, 0111, and 100. So this is the different combinations, and here you can see the new subnet mask 111, that is 224. Now according to this subnet table, we have to do it in Cisco packet tracer. See, this is the topology which I did. This first subnet, that is 192.168.100.0. So this address we can't use. So first usable host address is 100.1. So what I did is I'll give this PC's IP address as see 100.1, and then the subnet mask is 255.255.255.224. And what we'll do is the last usable host address we will give it to the router. Okay, that FA00 interface we will give it as you can see it here. We give it as 100.30, and this will be the default gateway for this PC. In the same way, for this network, like you can see, I'm following this. Okay, so for the next network 100.32, 100.33 I will be assigning to the PC, 100.62 I will assign to the router. So 100.33 to this PC, subnet mask 255.255.255.224, and the router's FA10 interface will be the default gateway. In the same way you should do all of these things. Since I have already done, I just explained you. Just go to the PC, click on that, go to IP config, and then type the IP address, the subnet mask, and the default gateway. In the same way for router also, see one more thing. To show this port labels, you to go to options, then preferences, then you should always tick this always show port labels, so it will be easy for you. So FA00 interface, you should go to fast ethernet 00 and give 100.30. The same way you should give the address to each and everything, and then it's done. Like we can send the packets. So now you need to go to the simulation mode. Only ICMP should be selected. Now you can see the packet is moving. So like it's very easy, just follow this subnetting assign the IP address, and it will be easy for you. I want to send. Now you can see the packet is moving. So for this topology I explained you how to do this. Like I told you, the first usable address you should give to the PC, and the last usable host address you should give to the interface. Okay, I hope you understood this topology. This is the second topology which I have been given. Here 10 hosts, 8 hosts, 14 hosts, and 12 hosts, and then you have this routers connected to it. Now here again I have been asked the question, based on the topology how many subnets are needed. So let me tell you how to calculate. This is one network, this is second network, third network, fourth network. This connection between the router is also network. So fifth, sixth, and seventh network. So we altogether need 7 networks. And how many bits must be borrowed? As I said in the previous topology, 2 power 3 8. So we need 3 more bits. So how many subnets does this create? It creates 8. Now how many usable host address does this create per subnet? That is 2 power 13 minus 2. And then this and all is same like above. And then according to this subnet table, again we need to do this. Okay. So again the same thing. The first usable host address to the PC and the last usable host address to the router. So I'll to show you one example. Desktop, go to IP configuration 30.0.1, and the fast ethernet 00 interface should be given to the default gate, and this is the subnet mask. So in the same way you need to do for everything. For router also the same thing. go to config, click on the serial 2 click the port status as on, and the clock rate you should keep it as 64,000 for basic. You can keep any clock rate, but like it's better to keep it as 64,000. The same way for this interface also you should do this. Now you can see the packet is moving. I think this is the auto capture play. The same way you can send packet from anywhere. Show you capture forward. You can see the packet is moving. Is returning back. So I hope you there's nothing much like you should know how to do the subnetting. Once this table is done, it is very easy to do subnetting, right? So first usable address you should give it to the PC, and the last usable host address to the interface of the router, and then you can send packets to check the connectivity between the networks. So I hope you understood this like this subnetting thing. First, one more thing, like I wanna remind you that you should be very clear about the IPv4 addressing, the subnetting, and the classes, how to do it. So once you are familiar with that, then only you can like progress into subnetting. Once you learn this, I guarantee you that this will be one of the easiest thing which you have ever done in your life. So thank you for watching my video.